Hi. One of the things I wanted to do this semester was to try to come up with something new, and that was do each module in like 5 minutes. I didn't do this for module one. Rather than make this introduction any longer, I'm not even sure if this is going to work. I'm just going to try to tell you everything I think you should know about module two in 5 minutes. Here we go. So module two is basically about frequencies. When we talk about frequency, we use the letter F to talk about frequency. Now, when we talk about relative frequency, that means we're talking about relative to the whole. Now, the whole sample or whole population, the whole sample, total sample is N. So when we talk about something's relative frequency, we're simply dividing it by the total number. For example, I have a bag of Skittles here, and there's a certain number N in them. And there are a number of different types of Skittles in this bag. And let's say there are 50 Skittles in the bag, 10 of them are blue. The frequency F is 10, N is 50. So the relative frequency would be 10 out of 50 or 0.2 or 20%. And as we learned when we started doing this in module one, the symbol P is designated for proportion, probability, or percent of the sample. So if I take this as a sample of a potential bag of Skittles, and the number of Skittles in here is a sample size N. If there are 50 Skittles in here, 10 out of 50 makes the probability or proportion P equal to 0.2. So that's why we use that symbol there. But we see when we talk about relative frequencies, for example, I want to share with you this Excel screen real quick. Excel here. Okay. When we think about relative frequency or frequency at all, we're going to be making counts. So here is that data from module one. I want to turn this into a pivot table. I got my quick access toolbar up here. I just hit pivot table, and boom, this is now a pivot table. I can look at the different carriers which are used and count them. So I can see that there were 4 different carriers used. The frequency F for this particular variable, this variable could be X. 2 out of 10 is the frequency out of the total. If I want to talk about that in terms of relative frequency, I can show values as percent of column total. So 20% are AT&T, and that's the relative frequency when the actual frequency is 2. Now, the way we can represent different frequencies would be perhaps using something like a bar chart. In this case, we can see that 20% of people in our sample, 20% are AT&T customers, 30% are Sprint customers, and so on. This is a bar chart. This is not a histogram. A histogram, your textbook is going to argue, is only used for continuous data. But as we saw with the restaurant evaluations, which are, not handy so far. Oh, here they are. Yeah, let's make this one up here. So a histogram such as this, make sure I'm checking the right screen. A histogram such as this. This is discrete data because I asked people to give me a rating on a scale of 1 to 10. I didn't say you could give me a 6.5 or 6.7, but they could. But regardless, we can see that this is a ordered horizontal axis here for a quantitative variable. We can do histograms with discrete data if it's numeric. It's a little bit more of a challenge, and in fact impossible, if you don't have numeric data across the horizontal axis. We're back to here and come back to our pivot table. So right now we're talking about relative frequencies, but if we wanted to calculate something else, let's say, for example, the amount of data used, and I don't want this relative, I want this as frequency here. Again, there were 10 people in our sample, and we can see that 2 people used 0.6 of a gig of data. And again, this is X. So this is someone used 0.6 gigs of data. In fact, 2 people used 0.6 gigs, and so on. Now, we could use the pivot table to generate an average for us. And if we wanted to calculate the average, we could just take data used in here, and as opposed to saying sum, we say, you know what, let's go ahead and give me an average. So the average amount of data used was 2.28 gigabytes for 10 people. The total amount of data used would be 10 times that, because there were 10 people, or 22.8 gigs. But if we look at each of the 10 people here, we could actually use this information to generate a give me a new sheet. It looks awkward how I had to do that. Don't worry, it was necessary. But right now I have right here this same 10 respondents. If I wanted to calculate this by hand, I would use paper and pencil. But since I have Excel here, all you need to do to calculate the total sum, I hope 5 minutes, shush, is say this is X and this is F, because this is our observation, X, and this is the frequency, how frequently occurs. The total number of gigabytes would be for each one of these X's, how many times it occurs, and add them all up. In other words, 2 for the frequency here indicates that it is one person who used 0.6 and another person who used 0.6. One person used 1.1 and so on. 2 people used 2.1. And I would be adding up 0.6 plus 0.6 plus 1.1 plus 1.2 plus 1.6 plus 2.1 twice, because there's 2 of them. We have a mathematical operation for that, and that's multiplication. So if I just take X times F, repeat this for the entire column. I said the entire column. I said the entire column. I said the entire column. Thank you. I can see that the sum of all of these is 22.8, as we did before. The sum is 22.8 gigs. That's the sum of X times F. In order to get the average, and this is, again, this is the sum of X times F. To get the average, I need to take that number, the sum of X times F, and divide that by the total sample size. And that's what gives us an average. It would be the sum of the frequencies. Oh yeah, how about the sum of the frequencies? So there are 10 observations here, because I know that the sum of the frequencies gets me 10. And 10 was my sample size, 10 observations. That's why the sum of all of these frequencies is equal to 10. I take 22.8, which is, again, the sum of X times F, divide that by the frequency, and it says the average person uses 2.28 gigs of data. That's going to get us through most of Module 2. The other things that we would need to be thinking about here would be what the shape of distributions are. We don't spend too much time talking specifically about what a normal distribution looks like, although we spent some time in class. This is the shape of a normal distribution. Now, a normal distribution can have a skew, which means it leans to the left or it leans to the right. What do I mean by leans to the left or leans to the right? A normal distribution is a histogram, which has this bell shape. Now it's a histogram, so we did 1, 2, so far over to 10, something like that. Now, if we were to have something which is steep on one side, on the left side, and has a tail on the right side, like the one I just wrote in pencil there, it looks like the palm of my right hand. This is my right hand, and this is the palm of it, which is steep on one side and a tail on the left side. Palm starts with P, positive starts with P. This is the right-hand rule. Positively skewed distribution looks like that. On the same hand, I don't want to say on the other hand because it's still the right-hand rule. I can start with a normal distribution, but if I put the tail on the left-hand side, then it looks like tail on the left-hand side, then it doesn't look like this anymore. Now it looks like the knuckles of my right hand. And what letter does knuckles start with? Not what it sounds like. It sounds like it starts with N, and that's a negative distribution. So it's got to work for the right hand. If it looks like the knuckles, it's negatively skewed. If it looks like the palm, it's positively skewed. And that's going to tell you about the skew of a distribution. The only other notes I think I have to remember from here, I would have written in the Sakai module, but it's mostly about relative frequencies and frequencies. And on a histogram, we can demonstrate either actual frequencies or relative frequencies. It doesn't matter. It won't change the way the histogram looks, whether, and we did that before here when we were looking at those, we did with a bar chart, but it can work just the same with a histogram. Let me pull up the one I was looking at here. So when we generated a, well, this is a bar chart. This tells us the frequency over here of the 10 people and how much data they used. I got to get better at doing this in 5 minutes is what I got to do. We say that 2 people used 0.6, 1 person used 0.1. Now, if we displayed this rather as a frequency, but as a percent of the column, we can see that 2 out of 10 is the same as 20%. The shape of this distribution hasn't changed. We've just changed the vertical axis to say relative frequency as opposed to frequency. That's the only way that's different. So 10 minutes might be a little more accurate than 5, but that's what I think I need you to know out of Module 2. There might be some other things, but that's the basics. Anyway, try to be quick.